Hello, welcome back to our little corner on the web, where we discuss math problems to hopefully nurture and encourage interest in math. Today, we will discuss question 15 of part 1 of the PMO area stage, of the 26 PMO area stage. Thank you to organizers for freely sharing the questions. Question 15 states, how many ways are there to arrange all the digits in the number 629,999,999 so that the resulting number is divisible by 37? So this is actually one of my, I guess, favorite problems on this set because it didn't appear obvious how you first would solve this, I guess, unless if you know the divisibility rule by 37. So I played around with the numbers that were given, and I ended up deriving a divisibility rule that's similar to the divisibility rule for 11. So maybe let's have a refresher first on the divisibility rule by 11. So if we have a 9-digit number, similar to the 9-digit number we have here, we can rewrite that 9-digit number as I plus 10H plus 100G plus ... up until 100 million A. Okay. And then we can sort of rewrite the coefficients of each of those digits to be 100 minus 1H, and then 99 plus 1G, and so on and so forth. And what you'll realize is 11, 99, and 8 nines, basically, right, are all divisible by 11. So we can again rewrite it as I minus H plus G, right, minus F ... plus A, and more terms which are all divisible by 11. So since those terms 11H, 99G, and so on and so forth are divisible by 11, we really need to only worry about I minus H plus G minus F ... plus A. If that is divisible by 11, the whole thing must be divisible by 11. Okay, so what did we find? How does this relate to 37? Well, if we have one such permutation, we note that 999 is divisible by 37. Okay, so we can rewrite our string, right, as 1 million times ABC plus 1,000 plus DEF plus GHI. Okay, this means that we can split the ones away from ABC, DEF, and GHI so that the resulting 999,999 times ABC will be divisible by 37, and the 999 times DEF is divisible by 37. So we only need to worry about the sum of the 3-digit sums, or the sum of the 3-digit numbers ABC, DEF, GHI. Okay. Okay, so that this one's just bringing it down more to make it obvious that 37 does divide this latter term here. Okay. So given all these 9s, which made it hopefully makes it now easy, is if we can find the sum of ABC plus DEF plus GHI, and that's divisible by 37, then we're done, right? But since there's so many 9s here, there are cases where DEF is all 9, or GHI is all 9, or ABC is all 9. Those will be divisible by 37. So we only worry about the non-999s. Okay. So because we're worried about the sum, if we write it this way, ABC plus DEF, plus GHI, there's only 2 cases. The 2 and the 6 are in the same column, or the 2 and the 6 are in different columns, meaning middle and the first or something like that, right? So let's take case 1 first, right? For simplicity, we'll assume ABC is 999, but it doesn't really matter. It could be that DEF was 999. It doesn't affect the sum. Okay. So if 6 and 2 are in the same column, it could either be in the third, the second, or the first column. Okay, we investigate each of these cases. In the first case, we know that we're 10 short of a 999 plus 999 plus 999, right? So this, sum of 3 999s, we know it's divisible by 37. So we'll be 10 short of a multiple of 37, which doesn't work. Okay. The next one, if we write it all out, is 100 short of a multiple of 37. Okay. So again, that doesn't work. Okay. The last one, we could think of it as 999 plus 99 minus 1, or 999 plus 999 plus 999 minus 1,000. Either way, it's either 1 short of a multiple of 37 or 1,000 short of a multiple of 37, which also doesn't work. Okay, so there's actually no solutions where both the 6 and the 2 are the same column. Okay. So case 2, they're on different columns. Okay, meaning either first and second, first and third, second and third, right? So for simplicity, we'll assume first that 2 of these are 999s. Okay, 2 of these 3-digit numbers. Again, it doesn't matter because we moving, let's say, this 2 up to the top here doesn't change the sum. Okay, so for simplicity, we'll assume that 2 of them are 999s. So we really only need to look at one of the possible combinations, meaning 269, 296, one of the permutations of 296, to see which ones are divisible first by 37. Okay. It turns out that there's only 3 of those combinations, 296, 629, and 962, which are divisible by 37. The other 3 are not. Okay. So now it's just a matter of finding the number of arrangements we can have where the 6 and 2s are sort of spread out in the different columns following the pattern of 296, 629, and 962. Okay. In each of those cases, for example, we have 296 here. This 2 could be placed in one of these 3 slots, right? And this 6 could be placed in one of these 3 slots. So there are 3 ways in which to place the 6 and the 2 along the 3 columns, okay? And there's 3 combinations that work. So in essence, there's just 3 times 3 times 3 ways of arranging the 6 and the 2s appropriately, okay? Hopefully you find this solution useful and educational. If this was helpful to you, do hit like and subscribe. Thank you.